Right. Hi, everyone. It's Dr. Ahmed Mahmoud. I'm a research associate at the University of Leicester. I'm part of the Endangered Archaeology in the Middle East and North Africa project. And it's a project that is a collaboration between the University of Oxford, University of Leicester, and University of Durham in the UK. So today I will be talking about the tool that we developed to monitor disturbances and threats to heritage sites, which is called EAMENA Machine Learning Automated Change Detection, or MLACD. I will be taking you through the training documentation that we developed at the University of Leicester, which is a guideline of how you use the tool. And I will be also doing some demonstration of the functionality of the tool as well. And before doing that, it would be a good idea to also give you a little bit background about the project or the EAMENA project. So the Endangered Archaeology in the Middle East and North Africa project, EAMENA, started in 2015, which is a collaboration between Oxford, Durham, and Leicester, with four main objectives, starting with developing and creating a baseline inventory or a database for heritage sites or heritage records across the MENA region, from Mauritania to Iran, recording all the sites and heritage sites in the area. And the idea is to track the condition disturbances and threats that affect these heritage sites. In this project, we also develop remote sensing methodologies and frameworks to record or monitor heritage sites. And we do work with local partners and local authorities across the MENA region. And we do share with them these data and methodologies as well to aid for responsible cultural heritage protection and to maintain these heritage sites. So this project is generously funded by the Arcadia Foundation and also the British Council with the Cultural Protection Fund. So far, we have developed this EAMENA database, we share it with our sister project, the MARIA, or the Maritime Endangered Archaeology Project. This database is developed in Arches, and you can have access to this database where we hold all these heritage records. There is different licenses that you can get to when you ask for permission to use the EAMENA database. So far in this database, we have recorded over 200,000 heritage records, which is quite a lot across the MENA region, as you can see from the map here. Having this large number of heritage sites actually resulted in creating a significant challenge to monitoring these archaeological sites. And that is why we started developing some questions about how can we monitor these archaeological sites. And the four main questions that we identify to effectively monitor archaeological sites were the first one, which is has a change or a potential threat being observed within the heritage site. So can we see a change or there is no change in this specific heritage site? And the second question is also to understand the type of change or threat that has been observed in these heritage sites. So can we see, for example, the impact of construction or urbanization? Can we see sites that are impacted by agricultural practices or any different type of climate impacts, for example, such as floods or earthquakes in heritage sites and the impact of that on them. So specifically defining the type of change or threat in these observed heritage sites. So another important factor, which is when did this change or threat occur? So, and this is specifically the idea of understanding within your time period with or time series of let's say, for example, years. When did this specific change happen? And finally, is it a continuous threat, or was it only a one-time event that happened? For example, a flash flood hit some area and disturbed some of the heritage sites there. So answering these four questions will lead to effective understanding and effective monitoring of archaeological sites. And that led actually to start thinking about developing different remote sensing methodologies to monitor these heritage sites. So the first automated change detection tool was developed by our former colleague, Dr. Luis, and that tool was developed in Google Earth Engine, which I'm going to be talking quite much a lot today about it. Basically, monitoring and detecting the changes, or whether there was a change or no change in a specific heritage site using by comparing two satellite images. So, however, that only answered the first question, which is, can we see a change or no change in a specific site? Then, as part of the development of the automated change detection tool, we started working also into answering the rest three of the main questions, which is the type of change, detecting the type of change, the time of that change, and whether that change is still ongoing or not. And that actually led into the EAMENA machine learning automated change detection tool, which is I will be specifically talking about today, which is the focus of our recording today. So the EAMENA machine learning automated change detection tool is also developed in Google Earth Engine, which is a cloud computing service that allows you to access huge amount of data sets such as raster images or satellite images, weather data, and so on. But it also allows you to analyze these data as well. Which I will be showing you that in a minute. So the MLACD is developed and uses actually the harmonized Sentinel-2 level 2 optical imagery, which is a 10-meter spatial resolution. There is different inputs, as you can see from the machine learning ACD framework on the right here, which are the satellite images. As I said, it's Sentinel-2 and the study area, so the area of interest that we want to investigate. The feature of interest, which is the archaeological sites that we want to assess. And then as we said, we use machine learning models, specifically the random forest, to process these series of satellite images and generate land classification maps. Therefore, we need to also train to collect training samples and validation samples to train our model and random forest model to generate these land classification maps. The processing, there is several stages of processing of the satellite images in order to get to the final results, which is the automated change detection, which is specifically related with understanding the impacts on and changes and threats on heritage sites. So the processing is different. There is different stages, different analysis that includes filtering the data, training the classification model, doing the classification, specifically supervised classification based on the random forest algorithm, and also doing the change detection analysis. And this, as we say, it's an automated change detection. So all the results that are generated automatically. We get different type of results that includes land classification maps, change detection maps, time series change detection, and charts, and also some statistics on the archaeological sites under specific threats or changes. I think one important part of the tool here is that it is also developed with a user interface that allows users with limited remote sensing and GIS and also programming skills to make it easier for them to understand the threats in their heritage sites and their investigation. And also it allows them to very smoothly and easily do execute these analysis and the repetition of that and the frequent analysis for heritage site detection. So this is just kind of a brief about the EAMENA machine learning automated change detection, and from that I will move to the next part, which is I'm going to show you the training documentation. I will also jump into the code, the machine learning code. So as I said, we developed a training documentation so that it can give a step-by-step of how to use the tool. It's called EAMENA Machine Learning Automated Change Detection Training Documentation, which you can find in our EAMENA project, under our EAMENA project GitHub repository. And if you go down to the EAMENA Machine Learning ACD and click there, it will lead you to the forked repository of the machine learning ACD. You can find here, for example, if you click here, you will find the article that we published, and it kind of give you much detailed information about the tool and how we use it, and we implemented it on a specific case study to kind of just showcase the use of the tool and some of the results that we got in West Libya. The main article is called "The Novel Machine Learning Automated Change Detection Tool for Monitoring Disturbances and Threats to Archaeological Sites." So you can find that of open access, and you can download it, or you can just browse it online and see different results and outputs. So as I said, there's different types of information that you can get here on the EAMENA repository. So most of the updates that we do, you can find it here on the repository once it's forked. There is the training documentation, which is the English version, and there is also the Arabic version of the training documentation. So this tool, as I said, we do work with our local partners. So we in the MENA region, where Arabic language is the main language there. So we translated the training documentation. We've run series of training programs actually in Arabic. So we also provide training documentation of how to use the tool to monitor threats and disturbances to heritage sites in across the MENA region. So you can, as you can see here, there is some description of the tool, how it's, what it does, and what it uses, and also there is the main code as well, which actually you can find it in different ways, but this is also one of the ways that you can find the latest version of the script of the tool as well. So if I go back to the training documentation here, so when we say Google Earth Engine, so it's as I said, it's a cloud computing service developed using the EAMENA machine learning ACDs developed using JavaScript. And I'm going to show you that in a minute as well. So the first step when you use the machine learning automated change detection tool is that you need to have a Google Earth Engine account. As I said, the tool uses the cloud computing service of Google Earth Engine and developed in JavaScript to process time series of satellite images to create different land classification maps and detect changes and threats to archaeological sites. So some of the prerequisites that you need, which is to use the EAMENA machine learning ACD tool, is that you need, first of all, you need a Google Earth Engine account. So to sign up for this, for Google Earth Engine, you can click on this link here, and it will lead you to the main web page of Google Earth Engine. And then you can click on register and then follow and then you can follow just the registry steps. It depends on, it varies and depends on whether you are doing commercial or non-commercial. But for research purposes and teaching, and so it's free. The tool is provided for free. So you can just, if you are doing this type of research work, then you can just sign up for the non-commercial license. So once you have your Google Earth Engine approved, you can come back to the training documentation, and you can start the browsing the Google Earth Engine by going to googleearthengine.com. It takes you to the code editor, which is the main area where you develop your scripts and functions, and this is we already did that for the EAMENA machine learning ACD. So if I just go back here, so for example, this is how Google Earth Engine will look like, and this is the code editor. If I'll just show you this one here. So this is the code editor, and there is different functions and tools that you can see from the main code editor or Google Earth Engine code editor. You can see that you have a map at the bottom with different tools, for example, geometry tools, zoom, which is basically, if I go back to my main browser, so this is the code editor. These are the geometry tools where you can, for example, pan or points, or you can add polygons. You can also add new layers. For example, I'm going to show you that later as well. Um, uh, I think one thing, if I go back here as well, I think it's important to also know the console, the task tabs, and the inspector. So the console, for example, is the tab that allows you to see all the outputs that the code editor generates. For example, also the task manager as well. You can also see some of the tasks that it was specifically defined here on the code editor to be executed. For example, if you want to export an image or a table or a shapefile, then you will see that these results on the task manager, such as these ones here. Um, one important tab as well, which is the inspector. So it allows you to, as it says, click on the map to inspect the layer. So if you click here, for example, it gives you the coordinates, different informations. Once you have more layers, you can use it to get more information about the layers that you have. And later on, we're going to have a layer here, which is called additional layer here, which is called layer tab. So as you can see, we can flip between the map and satellite. And I'm not going to go into much details here. We have on the top left here, we have the scripts, the different type of scripts that all the scripts that actually we developed. You can see them here. You can see all the scripts that you own and you developed over time. So you will have large number of scripts here. So for documentation here, so it allows you to see the different type of tools and functions that you have, for example, and then you can get more information about these. You can get more information about each tool and how you use it as well. Assets, in terms of assets, there is a different type of assets. Basically, they are either rasters, shape files, tables, Excel files, and so on. So all these data files or data that you have, you can upload them. So this is basically having a folder of that contains your data. In terms of running these in terms of running the script and executing the script, there is the main function, which is here, run, this run button here. And this button is quite important actually, because once you click on it, it will execute all the scripts that you have, or all the line of codes that you have here on the code editor, right? So this is our EAMENA machine learning ACD script. It's quite a lengthy script, and you don't have to worry about it. So all the information here are done, are developed actually to allow you to automatically do the analysis without the need of going into through all of these analysis or line of codes, apart from these lines here, and I'm going to show you later how to deal with them and work with them. So yeah, so as I said, when you want to start using the machine learning ACD, the tool, we developed a preset case study just to kind of take you through the functionalities of the tool, and at the same time, it also allows you to see and also you can have this link actually to access the code, the original code of the machine learning ACD. So for example, once your Google Earth Engine account is approved, you can just come back here to the Bani Walid case study. And this is our main original machine learning ACD code. And then you can just click on this one. So once you click on this one, it will just basically it will take you to the browser, and then it will show you the main code and also the tool. Okay, so I'm just gonna, this one and this one are the same, so it's just I'm just gonna continue on this one. So as I said, to run your script, you need to click on run here. So once you click on the run button, it will execute all the scripts that you have on the code editor. And as you can see, we have here the EAMENA machine learning ACD user interface. So you can see on the left here, we have a user interface that appeared where it will allow us to follow the steps step by step to understand and analyze the heritage sites in our case study. In this example, it's the Bani Walid study area. So yeah, as I said, you can then once you click here, you can save and then follow. You can save the script. This one, for example, if you just click here, and then this save button will show, and then you can just click save. It will ask you to give it a name and then a folder. You can just give whatever name that you want. For example, MLACD or any, and then you any other name, and then you just click OK. So in that case, you will have the original code saved into your scripts here folder. So to get started with the how to use the tool, I'm gonna talk in a different video about how to use and modify and adapt the tool to use it for other case studies rather than just following the case study of Bani Walid. Right, but we have three type of inputs as or three main stages divided. Our workflow is actually divided into three main stages, which is The first one, which is defining the variables and inputs, and then the emit classification analysis, and then the identification, the third stage, which is the identification of threats on archaeological sites. So I'm gonna quickly try and show you how to use the tool. And then, as I said, on a different video, on a separate video, I'm gonna be taking you through how to use the tool and how and adapt the tool for a different case study and how to update to make the updates here on the code editor to suit your new case study. So once you save the, the tool code, you click run. Then once you click the main run here button, then you get this user interface. So as you can see, there is some description here. You can see that the tool, it kind of gives a description of the tool, how you use it, and the functionalities of the tool. And then there is also the steps. So the first step when it comes to using the EAMENA machine learning ACD, it asks you to define the start date and end date of the study period. So as I said, we have a case study. Our case study is Beni Walid. It's an area. This is the study area that we defined, and we defined using the geometry tool, and I'm going to show you how to do that as well. So either you can have your study area drawn here using the or added using the geometry tools. So for example, you can say new layer, and then you can give it, if you click here on the settings, and then you give it a different name, say area of interest, and then you click OK. So you can see that it added a new layer here. And then, for example, we can go somewhere else. So for example, let's say here, and then we can select this geometry draw shape tool, and then we can start drawing based on the area that we know. So this could be done from a satellite map like this, or from a map that you already know. If you want to update the polygon that you created, so you can just click on the pan and then click here, and then you start changing these nodes. So this is one way. The other way is that you can apply and upload. You can upload your study area. So, for example, upload it as an asset to the Google Cloud, and then you can import this into your script. So this one could be this should be a share file that was generated or created using other GIS software such as QGIS or ArcGIS, or you can also create it in Google Earth engine as well. And then you can upload it and then add it to your import it into your script. So, and that actually leads us to an important point, which is the script, the machine learning ACD. There is, as I said, there is some inputs and variables that needs to be defined, and these are the sites, which is the archaeological sites, and it must be called sites, and these are specifically defined here on the training documentation. So how to define the study area, for example, the archaeological sites under investigation, the training samples, and the visualization parameters and values and names for the charts and outputs. And this is also part of the updating and um, updating the tool. And I'm gonna also talk about that later on how to do it. So if I go back, we have these inputs. We have the sites, we have the study area, um, we have identified different type of land cover classes in our area. So I'm just gonna delete that one because it's, and now I'm just gonna go back to Beni Walid here. So this is our study area of Beni Walid. It's an old town in western Libya, and there is some medieval um, buildings and old buildings, for example, and settlements in the, as you can see in the um, within the new city of Beni Walid. So, and as you can see that there is significant impact of urban expansion to the heritage sites of Beni Walid, and this is actually across the city of Beni Walid. So you can see the expansion of new buildings. You can see also some, I don't know, this could be some trash or dumping areas. Um, so all these are impacting our sites and their investigation. So yeah, so as I said, we identified 5 classes: bare soil, mountain areas. We identified queries, which is there is a coring activity on the east side of Beni Walid and also to this spot as well. So there is some coring activity um, here as well. So so we classify these areas coring areas. There is urban areas and there is also vegetation areas. So there is agricultural practice that that is happening across the along the Wadi of Beni Walid. Um, so these are our input sites, study area, and training samples. So if I go back to the training documentation, um, there is, so for example, let's say that we want to understand, we have, um, um, we want to understand what is happening in terms of threats and disturbances um, um, on our heritage sites in Beni Walid. Which are these sites actually? It's about 211 sites scattered along the Beni Walid area. And I'm going to show you that in a minute as we get this, we get the sites here on the displayed on the layers tab. So you can, as you say, as you see that you can click here and then you can either also switch to see the switch off the different layers that you have here. So if I go back to the user interface, there is some stages. Define the first stage is to define the start and end date of the study area, defining the feature buffer distance in meters. Um, and this is basically you have a different type of you have sites and then you have the buffer of the sites as well. And then it says press run. There is this button that you click on, and then there is other steps that I'm going to show you in a minute. So let's start with defining the start date. So for example, we are interested in seeing what happened in Beni Walid between 2013, 2023, January 1st, and then up to the end date is, say, 2025, also January the 1st. It doesn't have to be these specific dates. It can be any date that you interested in understanding the type of threads that happen between them. And then the second thing is that we are asked to define the feature buffer distance, which is it's a distance in meters from the central point of our heritage sites. So let's say, for example, we specified 100 meters for this example here. And then it says press the run button to execute the first stage of the processing. So there is different stages on the you can just click right here. I did press run. So there's different stages on the script that will not appear to the user, and that is why we developed the user interface. But actually there is on the background there is different execution of there is different tasks that the Google Earth engine is actually doing some analysis and some work that we specify clearly on the code editor. As I said, the images that we use are Sentinel-2 images that you can go back up to 2017, and then up to today. So once, as you can see, once we click the run, it gives us this these new tabs, which ask us actually the 4th step, which is say select year for training data, which is, so for example, this one here. And so if you click on this drop down menu here, we see that as I said, we go back to 2017 up to today. So it's just we put some dates on in the future, which is 2030. So when it comes to selecting year of training or year for training data, actually before doing that, because I was just trying to show you the sites and also to show you the sites of buffer, the site buffer. So these are the sites that we have in Beni Walid. As you can see there, some of them are recorded on previous studies. Some of them were recorded recorded using remote sensing as well as part of the EAMENA project framework, as well in documenting heritage sites. So for example, this one, and this is actually the buffer, and this red circle here, we specified 100 meters, and that is why it kind of covered all of this area. And so that's why you can change the buffer distance into whatever you feel will suit your case study. Yeah, so for example, this one, if we want to understand more information about this specific points, or example, if I go here to the inspector and then click on this point, for example, it will give me more information about this specific site. It will give me the coordinates in terms of pixels, but it will also give me, for example, for this one here in sites, it's a feature. If I go to the properties, I will see all the description of this specific point, who recorded this point on, for example, because we downloaded it from our EAMENA database, so it will give you the EAMENA database, the location, it will give you some information about the area, about the site as well. Yeah, so this is one of the things that we can see. Also, we have more information here about the training sample and validation samples, and I'm going to go back to this later to show you more information about it. So if you recall, I clicked on the third stage, and these two panels appeared, and also this panel appeared as well with selecting year of training. But on the console, there is, as I said, there is some results. Most of the results that we have will appear either on the console or on the layer tab. So on the console, the first output is actually the Sentinel-2 images, and you can, if you just click on them, you can get more information about the images, about the different images that there is 289, but actually these are covering all of the study area because it's a very large study area. But these, one of the tasks that we specifically, one of the processing or process that we developed within the code editor here is that to mosaic and combine these images that were collected on the same day to cover our heritage or study area. So these actually are the Sentinel-2 filtered image collection, which we will be processing. We have 66 images. So if these images actually are collected from the, as you can see from the dates, because we specified 1st of January 2023. So all of the images from that specific date up to the last image that we have in our collection. So this is the image collection, or this is the image time series that we will be analyzing, and we will be doing the supervised classification for. So if you go back to the user interface here, the fourth stage is to select year for training, and it says from the drop-down menu, select a year for training data. So as I said, we were analyzing the dates from 2023 to 2025. So that means our training data should have been collected either on 2023 or to 2024, right? So for example, I will be selecting 2024 because I know that my data were collected in 2023. My data were collected in 2023, and I'll be also creating a separate different video for to show you how to collect training data. But there is some information about that here on the training documentation, which I'm going to be talking about later as well. How to collect, there's different ways of collecting training data or training sample, either from high resolution satellite images or from field ground surveys. These are the methods. So once I selected my year for training, you can see that say a new output appeared here, which is the training image collection. So it says like we are going to train on this. We are going to train our machine learning model based on this training image collection. Um, and then the fifth step, which is to choose emit dates. So it says from the drop-down menu, select the first emit date. And as I said, we have 66, 61, sorry, 61, sorry, 66 images. These 66 images, we can select any two specific satellite dates, specific dates. In this case, it's going to be specific satellite images that correspond to a date. To kind of understand more details about and investigate the changes between these specific two. But we're going to also have some results that will include all of our image collection or time series. But we can, for example, if we are investigating a flash flood impact on that happened in Wadi Beni Walid, for example, that happened in let's say let's say, for example, on the 28th of September. Sorry, the 28th of February 2023. So I can click that one. So it happened before, it happened after 20 February 22, February 28th. And then I can select my second image, that the two images that I want to compare. So for example, and then I can compare it with another image here. But in general, sometimes you want to compare the impact of 1 year of construction in the area, for example. So you want to see what type of construction impact that happened in your study area in 1 year. So for example, I will be selecting this one, and then I will go down to kind of similar date here, for example, or closer date to see what is happening, what has happened here. So once I selected my two images, then I will just press the second run button to execute the second stage of the processing. And basically, once you did that, you will start seeing change detection legend. You will see the classification legend here, which will tell you this is the bare soil, this is mountain, this corresponds to quarry, urban, and vegetation, which are your land cover classes. And we start to see we start to see some of the results here, some information about the classifier, the accuracy of the classifier, whether the classification results were good enough or it needs more tuning, whether that by generating new training samples or updating the image collection, training image collection, and so on. We also get some results in terms of the chain classification per or classification change in each pixel or in each location of the our study area. And actually that change detection or that classification change, so for example, pixels that was bare soil and then it changed into urban, for example, that means construction happened. Then we can see that new steps here appeared actually, which says, okay, change detection analysis. So for example, if, as I said, we are interested in seeing the impact of 1 year of construction in the area of Beni Walid, what is the impact of that on heritage sites or on our heritage sites in this the 211 sites. But before doing that, I will try and show you some of the outputs that we have here on the layers tab. So this is our study area. As I said, there is some validation samples, training samples. So these are training samples. These are the validation samples to assess the accuracy of our training model. But also we have the first image that we've selected, which is the 28th February 2023. It's a Sentinel-2 image. So as you can see, that is here it's displayed as near infrared green blue, and that's why the green these red pixels, actually these are grass or vegetation. It correspond to that. We can also view the second image, which is the second image that we've selected here as well, and then you can just try and play a little bit with them, so you can see some of the changes on the mainly on the wadi, some parts of the urban areas as well, but you can also see some shadows, and that might also impact the analysis. There is image difference. It's not appearing well here, but you can, if you click on this one, you can update the you can enhance the image to kind of clearly view the unique values of, or like unique image differences between them. So you can just say, for example, like that, and then stretch it, and then you can see this range here will change in a minute, and then you can apply that, and then you can see areas that change, either that was an increase or decrease. So I mean, like so this is one thing that you can do as well. There is other results as well, which is the NDVI, so which is quite important as well. So you can see the NDVI of an image. So it shows you areas of vegetation, and then also for the second image, so that clearly shows the changes in vegetation. Again, you can also play a little bit with the range to enhance the visualization of the images. But most importantly is the first classified image, which is this one actually. Yep. So the first classified image. So this is basically the land cover classified image. This is what the machine learning random forest algorithm managed to classify our study area, which is this one. If I in blue here, classify this area, or classify this first image, which is basically this first image here. This classified image correspond to the first image that we've selected on the using the user interface. Again, you can see that for the second image as well. So you get also you can get the a classified map or classified image for the second image. The performance of the classification depends on the training samples, and also on how the model will work in terms of classifying these specified classes on your study area. So we have bare soil, we have mountain areas, we have quarries, as I said, we have urban, we have vegetation. So for example, if I compare some changes between the first and second classification, you can see that there is some, for example, expansion of quarrying activity here. But we can clearly see there is some inaccurate results or inaccurate classification. And this is something that you have to be careful about. But I'm not going to be talking quite much about it today. One of the other results that we get is the binary classification image, which basically rate these areas that change from this first image to the second image, and then black are areas that with no change. So change, no change, but based on the classification, not based on the image subtraction or image division. And then again, there is also the classification, which is quite important, which is the main actually result that we want here is the classification changes between the two images or the two dates. And this is basically the change detection. This is the change detection analysis that will be built or based on this this map here. So if we, as I said, if we go back to the user interface, and we were interested in seeing the impact of construction or urban activity between those two dates, then we come to the change detection analysis. We click on, it says select change type. So it will be one of those options. And then we click analyze. So for example, I'm interested in seeing, so you will have a drop down menu of all of these here. So I'm interested in seeing areas that change from bare soil to urban. Then I will just select bare to urban. And then I will click analyze selected change. So once I do that, two new layers will appear here on the layers tab. The first one, if I just switch that off, the first one is change areas bare to urban. And then the second one is threatened sites, also bare soil to urban. So it basically, the first one here, the change areas is actually pixels that you can see now actually are in red. These are the pixels that change from bare soil to urban. And then the the second one, which is this, the threatened sites, is basically, if I zoom down to somewhere here, it will show us the buffer or the site buffer for sites that are impacted actually by the threat of bare to urban. Even if there is this one single pixel that change from bare to urban and overlap with the buffer of the site, then that specific site will be selected as impacted by bare to urban. It's taking a little bit, but it's gonna appear soon, and then I can show you I can show you the results of that as well. But while we are waiting for that, I can go back here to the console. As I said, there is some results of the classification, the overall or the accuracy of the classifier, the model itself. There is it seems that like the results are good here in terms of the classification. However, um, this sometimes this is also yeah, needs to be more accurate, or needs to be more investigative. Um, another type of results that we get here as well is that it says on the console, press to get land cover classification aerial time series. Yeah, seems like the threatened sites appeared here. So as you can see that these are sites or pixels, sites that overlap with chain pixels from bare to urban and so on. So all these sites, even so, for example, there is few pixels here, but still it will be counted as threatened by that specific threat. And then you can either decide before going to the ground to do more verification. You can decide which sites you think they are um, um, under this are actually needs more investigation on the ground or not. Um, So it says here, press to get land cover classification aerial time series. If I click on it, then down here, I will get this chart, line chart, which will show me the land cover classification aerial time series, or the changes that can occur over time. So we have 66 images, so you can see that we have 66 points here that represent the area. So the classifier will basically show me the and I'm actually a little bit skeptical about the accuracy of the model now here, because specifically for mountains will probably not change that much, or not change at all. So this, for example, this one here is actually seems like it's a misclassified image. So and then you start doing these investigations to kind of make sure that your results are accurate. Um, if you remember, when we clicked selected and then clicked analyze selected change, it also provided us with the threatened sites, the number of the sites. So we have these blue sites here. Threatened sites bare to urban actually are 186 of the 211 are impacted by this threat. And I have to mention actually that in the final article that we use, actually, we combine mountain and bare soil into one class. Um, and so we change the classification classes that, or the land cover classes that we have on our study area of Beni Walid. So that's, again, you have to think a lot about the classes that you have in your study area to make sure that the results later on will be more accurate. Again, so if we go back and we want to understand the impact of agricultural expansion, for example, then in our study area between those specific dates, so you can come back here and then click, for example, areas that change from bare to vegetation, or for example, I want to know areas that used to be vegetation and remained as vegetation. And so and that will actually tells me, if I select that, that will tell me that these sites actually, if there is pixels that remained, it used to be vegetation and remained as vegetation on the second image. So that means this site has been already impacted by vegetation expansion before this analysis period. So I'm going to be doing that, and then I will click analyze selected change, and then we'll see again here on the layers tab that we have change areas that used to be these are the pixels that change or actually remained vegetation in the two dates. And then it will also tell us about the location of these threatened sites, which are these actually. Yeah, so this is also one of the analysis that you can do as well, which is the change detection analysis. And you can do that for all of the other change classification change that you want to analyze. And then also basically it's also about these values here, names. It's going to change based on your study area and based on the classification or the land cover classes that you have here. So as you can see, it says 156 and so on, and then also it gives you more information about them and so on. So if I want to, I think there is also one important thing, which is, so for example, if I want to investigate what happened, let's say I'm just going to close these ones. I'm just going to these are all of the sites. So for example, if I'm interested in seeing, so this site here, I can see on this site there is a constructed building, or like at least a new constructed building compared to the old town here. And there is also here on this side there is some few buildings within the area of within the buffer area of the heritage site or old town or old settlement. So for example, if I want to understand the changes in a specific location, for example this here, then I can just click on this location. And then once I do that, it will appear, point location will appear here. And then also on the layers tab, it will say point location one, which is this one. So if I close it, open it, switch it on, off, you can see that the point. So this location, what it does when I click on anywhere on the map on our study area specifically, new chart will be automatically generated, and it will show us the changes. It will give us a classification time series of the changes in this specific location. So as you can see, I've just clicked on that, and you can see that this location has been an urban area for all of the study period, a part of those two dates, which used to be classified as mountain, which I believe it's a misclassification. But generally speaking, this location has been classified as urban. So, and this is quite important actually. Tool or part of the tool, which is you can start, for example, investigating. So for example, if I want to do the same thing here, then I can just click on this location, and it will say this is point location 2, and then it will start generating a time series classification chart, which tells me the classification changes between all of our study period, and examining the classes or the classification in all of the 66 Sentinel-2 images or classified maps that we have between 2023 and 2025 based on the filtering that we did. So as you can see here, this is quite a clean one. You can see that this is specific location. It used to be urban and it continued to be urban or construction. And that means this is definitely this side is actually is impacted by and has been impacted by construction and urbanization in this area for a long time. But for example, if I'm interested in, I can see that there is some vegetation or there is some trees in the area. So I can just click here and then see what is happening, whether that was before 2023. So if I have longer time series, so for example, from 2017, then I can start this, start seeing what type of changes in this specific location. Again, it's also for this location or for this building. We can, if we go back, then in time, then we can also see some newly developed buildings. So if as I said, I will just go to different area and try to see, for example, there is this vegetation expansion that is happening here. Then I will just click on that, either just using the pan, or I can click on the inspector and then it will give me this crosshair as well. So if you want to be more accurate in or sharp in specifying the location, but either using the pan or the inspector. So I clicked on that one, I got point cloud location 3. If I go down here, it's going to generate the third chart. And again, so as you can see, it seems like it's saying that this location has been vegetation for a long time before 2023, and it continued to be so up to today. And I guess that is why. So unless I expand my study period or time period, or whether there was like a new expansion of, I don't know, like new construction, for example, this building here or this building here. If it was constructed in 2024, for example, then I can see some of the changes that happened. So it will say like, okay, used to be the chart, it used to be bare soil and now it changed into urban, for example. So and so on. So I clicked on another example just to see what is the result for that building. So while I'm waiting for that, there is some other results that you can see here, which is says press to get NDVI time series at point, a specific point. And so yeah, so I guess this is the fourth one that I clicked, and it seems like there is fluctuation. So I don't know. So I think probably because the material type of the that specific building is quite close to the bare soil, so that you can clearly see this fluctuation between urban and bare. That could be one thing. The second option in that could be there was construction on happening in that site for some time and on some earth disturbance, and that kind of resulted in this one. But again, I'm gonna say that the accuracy of the classifier might have impacted the results that we can see now. So if I go back to the NDVI time series, so for example, I selected that one for the vegetation, and again, you can see that NDVI is an index that will tell us about the health or growth of vegetation, an indication of vegetation presence as well. So it's quite helpful in telling more detail about the one of the indices that will tell us about the changes in the specific locations as well. So I think this is most of the stuff that I wanted to cover here. There is also the on the task, as I said, like on the task, um, there is some functions that we've used within the code. There is some tasks that um, we develop within the code um, to execute and to export different type of the uh, results that we have either on the console or on the layers tab. So for example, the classified images that we selected, the classification changes, the different type sites and the specific thread that we selected here as well. So you can also export them here. And then, so to do so, for example, if we want to export the sites, just a shape file for the sites that are impacted by under the threat of bare to urban, then I can just click run here, and then it will say, okay, where do you want to save this specific where do you want to specifically save this shape file, and then you can either define your Google Drive, or you can save it as an EE asset, or you can, if you have a cloud storage, then you can do that as well, or BigQuery as well. So there's different type of saving and exporting your shape file, for example, here. And also, it also asks you whether you want it as to be saved as a camel or a CSV or a shape file, and this is based on the type format that you want. Then you can change the name as well, and then once you click run here, it will start processing your request, and then it will you will get an information or a notification that this task has been executed. Again, so if you want to export some of the images, so you can just click run, so, and then you can save it. You can define the scale, the coordinate reference if you want, and you can also save it as GUTIF, again in a drive, Google Cloud Storage, or as an EE asset, and then click run. So I guess this is mostly the tool, and I hope that I've showed you through the how to use the tool. I know this video has been quite long, but I guess I will be covering some of specific parts of the tool in different videos. And those ones will be a little bit small. So just to kind of recap, I've showed you the training documentation. I will be taking you through the training documentation on a separate video, but mainly here I've done most of it through our video recording today. So on the second video, I will be taking you through the adaptation stages of how to use the EAMENA Machine Learning ACD and adapt it for new case studies. This is the second video that I will do. I will also show you how to collect your training samples, define your study areas, and so on on a separate video as well. So I think that is everything related to how to use the machine learning automated change detection tool. Here is the main article, which is a novel machine learning automated change detection tool for monitoring disturbances and threats to archaeological sites. You can find more information about the tool and the functionalities, and more details about how it works, and so on. And also, if you look at the EAMENA GitHub repository for machine learning ACD, you will also find more new updated scripts and new updated training documentation, either in Arabic or in English. I think that's everything for this video recording, and I hope this video is helpful. And I'm looking forward to hearing from you either on our EAMENA webpage, or you can also email me or message me on our GitHub machine learning ACD repository, and also in our email as well. And thank you very much. Thank you.